Hey everyone, welcome to our notes on types of triangles and their angle measures. So in this chapter, we're going to learn about different triangles that we classify by both their sides and by their angles. So a lot of times when you have to classify a triangle, you're going to have two answers. One of the answers is classifying by their sides, and the other one is going to be by classifying the angles. So the first triangle that we're going to classify by its sides is called an equilateral triangle. And what that is a triangle that has all of its sides congruent. So how would I mark that in the picture? Well, I would take and do one tick mark per side, or two or three, what have you, but all three sides need to have the same amount of tick marks. The second type is an isosceles, and an isosceles triangle has at least two congruent sides. So if it has at least two congruent sides, that means an equilateral triangle is an isosceles, because an equilateral does have at least two congruent sides. And the third way to classify a triangle by its sides is a scalene, and in a scalene triangle there are no sides that are congruent. So we would have one, a double, and a triple. Okay, so that's the three classifications by sides. And I do want to mention that if it's equilateral, you want to say it's equilateral, give it its most specific name. Don't say, oh, it's isosceles, because if it's equilateral and you call it isosceles, you're not giving the most specific name. All right, next we're going to classify by the angles. An acute triangle has all angles that are acute. They're all less than 90 degrees. An equiangular triangle has all angles that are congruent, so I could draw that in the picture by doing one arc, one arc, one arc, and that shows that they're all the same measure. Their angles all measure the same amount of degrees. A right triangle is going to have one right angle, only one, and so in this picture it looks like it's right there, so we could put a little box in the corner that shows that the two sides are perpendicular, making this a 90-degree angle, which makes it a right triangle. And then the last is an obtuse triangle has one obtuse angle. So one angle that measures between greater than 90 and less than 180. Okay, so it's got to be greater than 90 and less than 180 degrees for that obtuse angle. Okay, so let's look at the parts of an isosceles triangle. Now, before we even do that, I want you to know how to name a triangle. We would literally draw a little triangle, and we could call this triangle ABC. Or I could call it triangle BAC, or CAB, or CBA, or ACB. It doesn't matter how you name the triangle, but we do name it by its vertices, and those have to be capital letters. The vertices, by the way, are the angles. All right, so in an isosceles triangle, it has what are called the legs, and the legs are the two congruent sides. So the two congruent sides, we call those the legs. The base is the side that connects the legs. Okay, or you could also call it like the non-congruent side. Okay, so when we refer to the vertex, every triangle has three vertices. Vertices is the plural of vertex. So in this picture, you could say A is a vertex, C is a vertex, B is a vertex. But now when we get to isosceles triangles, what we want to call it is the vertex angle. And so like I put the in parentheses and kind of stress it. The vertex is the vertex that's formed by the two legs. Okay, so in this picture, angle B is going to be the vertex. How I would name that is angle ABC is the vertex angle. It's the one formed by the legs. The base angles are the angles that are attached to the base. So in our picture, angle A and C, angles attached to the base. And here, what's going to happen in an isosceles triangle is angle A is always going to be congruent to angle C. The base angles in an isosceles triangle are always congruent to one another. Okay, let's now talk about the parts of a right triangle. So a right triangle also has legs. They're not necessarily congruent. They could be if you have an isosceles, right? But the legs are the two sides that come together and form the right angle. The hypotenuse is always the side that's across from the right angle. And it will 100% of the time be the longest side. Every time you have a right triangle, the hypotenuse is always the longest side. The legs are shorter than the hypotenuse. Okay, so the Pythagorean theorem, I'm sure we've seen it before, but the Pythagorean theorem is a way to find a missing side of a right triangle as long as you have the length of two sides. So if you're missing a side, you could use the Pythagorean theorem to help you find the missing side. So I'm sure you've heard a squared plus b squared equals c squared. I don't like to use that necessarily. I like to instead call it leg squared plus the other leg squared equals the hypotenuse squared. Because your sides aren't always going to be a, b, and c. They're not always going to, a lot of times students think it's always the missing side as your c squared, and that's simply not true. In fact, in this picture here, I will tell you that the way we would label these sides, so triangle notation, the vertices are always capital letters. The sides are always lowercase letters of the angle that's across from them. So here, if that's angle A, this would be side A. Here, if that's angle C, this would be side C, lowercase. And then here, if that's angle B, the side across from it would be lowercase b. So in fact, here, it wouldn't be a squared equals b squared, a squared plus b squared equals c squared. It would be leg squared, so c squared, plus the other leg, b squared, equals a squared. So that's why I don't like to be held to those standards that it has to be a squared plus b squared equals c squared, because that's not always going to be the case. It just depends on how your triangle is labeled. So I like to do leg squared plus leg squared equals hypotenuse squared. Okay, so let's take a look at our first example here. It says segment GO is the base of isosceles triangle GEO. Well, if GO here, if this is the base, then that means my other two sides have to be the legs. So in an isosceles triangle, the legs are congruent. Okay, to find the perimeter is, don't forget what perimeter means. It means you're finding the distance around. If you were to build a fence in the shape of this triangle, you would need to know how many feet or inches or meters of fencing would you need. So in order to find the perimeter, we first have to find x. So the one thing I know here, because it's an isosceles, is that x plus 7, that side, the leg, is going to equal the other leg, 3x minus 5. So go ahead, let's solve this for x. Pause the video, solve for x. Okay, hopefully you got that x is equal to 6. So now, if I have a value for x, I could plug it in to each side and figure out each side length. So here it's going to be 6 plus 7, 13 for segment GE. Plug in 6 here, 3 times 6 minus 5, this is 18 minus 5 is also 13. And that is good news because these two sides, if it's an isosceles triangle, they have to be the same length. And then when I plug it in here, I get 5. So the perimeter of this triangle, you would add up all the sides. So 13 plus 5 gives me 31. I don't have units here, so I just write 31 units. If it was inches, I would say it's 31 inches. Feet, I would say how many feet. But here we don't have units, so we just write the word units, or you could put a lowercase u. Okay, this leads us to another very, very popular theorem that we're going to use throughout the year, and that's the interior angles theorem. And so what this theorem says is that the sum, if you add up all the interior angles of a triangle, what you're going to get is 180. So if we took and drew a line through point B that's parallel to AC, let's see if we could explain why this theorem is true. Well, I would know that angle 1, the measure of angle 1, plus the measure of angle 2, plus the measure of angle 3 is going to equal 180 degrees. And the reason is those three angles, you piece them together, they're forming a straight line. A straight angle always has a sum of 100, or it equals 180 degrees. So now, because these two are parallel, what happens is angle 1 and angle 4 are going to be the same measures. They're congruent. So the measure of angle 1 is equal to the measure of angle 4. Here, 3 and 5 are also going to have the same measures. So if I was to go to my original statement that I wrote, that the three angles form a straight line right here, they form 180 degrees. If I go to that statement and I replace now 1 with angle 4, 3 with the measure of angle 5, notice what my new equation becomes. Instead of the measure of angle 1, it's the measure of angle 4. Plus, 2 had no one to help it, or to substitute in for it, so it's just going to be plus the measure of angle 2. Plus, and now I'm going to substitute in, instead of the measure of angle 3, I put in the measure of angle 5, and this is equal to 180. Notice these three angles, 4, 2, and 5, are my triangle angles. So I've just proven why this is the case, that the angles inside of a triangle are always going to add up to 180. All right, this next one is not in itself a very difficult theorem. I think most kids understand it and they could do it. However, it's used not as frequently as the inside angles, so kids will forget this one. So put stars around here, highlight this, write study, look at this when you're going to be studying so that you don't forget it. Because again, doing this is not a big deal. However, it's not used so often, so then kids forget this theorem much of the time. So let's look what it says here. It says the measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. So the exterior angle, how you would get it is if you took a side of the triangle and you extend it. So here we have 4. And so what this is saying is the measure of angle 4 is going to equal the sum of the two remote interior angles. I always call them the non-adjacent interior angles because 3 is adjacent to 4. So it's going to be the sum of the two non-adjacent interior angles. So again, not that, nothing crazy about this. It's just we forget it. So make sure that you do look at this before you take the quiz and test on this section. All right, let's see if we could explain why this theorem is true. We just learned the triangle sum theorem that says that the measures of the interior angles of a triangle, so the measure of angle 1 plus 2 plus the measure of angle 3 is 180 degrees. That's triangle sum theorem. Looking at this picture, we also know something about the measure of angle 3 plus the measure of angle 4. Those two angles are a linear pair, so they also add up to 180. So now I'm going to solve for angle 3, and I would get 180 minus the measure of angle 4. Why did I do this? Because now I'm going to substitute this expression in for the measure of angle 3 in my first equation. So I would get the measure of angle 1 plus the measure of angle 2 plus, now I'm going to replace the measure of angle 3 with 180 minus the measure of angle 4. So all I've done is replace, in my original equation, I replaced measure of angle 3 with 180 minus the measure of angle 4, and this is equal to 180. So notice what would happen if I subtract 180 from both sides, and then I'm going to add the measure of angle 4 to both sides. Look what happens. I am left with exactly this statement. I would have the measure of angle 4 alone on the right side, and that would equal the sum of the two non-adjacent, not next to, that exterior angle, the sum of those two measures. Okay, so now we're going to have some triangle sum corollaries. Can you complete these statements? The acute angles of a right triangle are. Well, I drew a little right triangle here to kind of try to visualize this. So the three angles of any triangle, these three angles have to add up to 180 degrees, 100% of the time. Now, if we have a right triangle, we already know that angle's 90. So what's left for these two to split? 90 degrees. So they have to add up to 90. Hopefully that makes sense. If the sum of the angles is 180, the right angle already took up 90 degrees of the 180. There's 90 degrees left for the two acute angles, so they are complementary. And this will just save you a little bit of time. Anytime you have right triangles, you don't have to add all three angles. You could just add the two acute angles and know that they add up to 90. Okay, there can be at most blank right or obtuse angles in a triangle. Hopefully you're all saying to yourself 1. a triangle can't have two right angles. If it had two right angles, that's already 180 degrees that the two angles have, and the sum of those two angles would be 180. If the three angles have to add up to 180, we can't have an angle that's 0 degrees in a triangle, so it has to be just one. Same goes with obtuse. Anything over 90, if you had more than one, your sum's going to be greater than 180, and the sum of the three has to be 180. And then the last question is, what is the measure of each angle in an equal angular triangle? We know each angle is going to be the same measure. The three of them have to add up to 180. So if we did 180 divided by 3, we get each angle's measure, which is 60 degrees. And that's for an equal angular. 60 plus 60 plus 60 is 180. Okay, let's look at example number 2 over here. Find the measure of ACB. So the order of this angle matters. ACB means that I am finding this interior angle. In order to find it, I need to find x. So we are going to use the exterior angle theorem. The exterior angle, 2x minus 11, is equal to the sum of the two non-adjacent interior angles. So we're going to get x minus 11 equals 72. X is going to equal 83. So if we want to find this inside angle, there's a couple of things we can do. If we know x is 83, I would do 83 plus 72. That's 155. What's left over for this inside angle to be 25 degrees. Or I could have plugged it in here. 2 times 83, subtract 11, I would also get 155 degrees. And then these two angles have to be supplements because they're a linear pair, so it would have to be 25 degrees for angle ACB. Be careful with the order. Some kids see this and they get confused. They think we're asking for the sum of the angles in a triangle. The answer is not 180. This right here is not a triangle symbol, it's an angle symbol, and they're asking me to find the measure of the angle. So don't make that common mistake of thinking, isn't that 180? No, this is a very specific angle, ACB. Okay, last one. Let's find the measure of each numbered angle. So I would like you kids to pause this video and try to find all of these measures. It's not necessary that you go in numeric order. You don't have to find angle 1, then 2, then 3. In fact, you may not be able to find those angles in that specific order. So I will give you a hint how to start off. I would start with this triangle right here because it's a right triangle. We already have one of its angles. Angle 5 is going to be pretty fast to find. So pause the video, find all 5 of these angles, and check your answer against mine. Here are the answers for 1, 2, 3, 4, and 5, the measures of these angles. So like I said, 5, you would say, okay, this one has to be 49 because the two acute angles of a right triangle are always complements. Then I found 3 because these 3 angles have to add up to 180. So if I know this is 90, I was able to find angle 3. Notice that that was not done in numeric order. Like I mentioned before, it does not have to be in numeric order. I just go around the picture and try to figure out angles that I'm missing and use linear pairs, use the fact that they're right angles here, lots of different ways. So if you did not get this answer, please make sure to ask your teacher in class next time you go to class. All right, that is it for these notes. Thank you so much for watching. Have a good one. Bye.